Hello. In this short video, you'll get the opportunity to do a little bit of exploring with simple harmonic motion. So we're going to start with a mass on a spring. So this is the PhET simulation here, masses and springs. And I've got 50 grams that I'm going to hang on here. And you can see it's oscillating back and forth, or up and down, I should say. And we're going to figure out the period. So to do one of them, that would be quite a bit. So let's just do 10. All right, I think that's 10. So about 5.87 seconds for 10 of them. So you can be as precise as you want. So you think about, is that the period or is that the frequency? So 5.87. All right, and then we will stop it and we'll turn this up to 100. And what I'd like you to do is to predict whether you think, and I'm going to have it oscillate 10 times again, if you think that the 10 oscillations will take longer or more time or less time. All right. So I got about 8.19 seconds for 10 periods. And by the way, um, I'm counting up and down. So from down to up and then down again is 1, then up and then down again is 2. All right, so let's try this one more time and we'll go up to 200. And again, think about what the pattern you saw before. With 50, 10 periods was about 5.87. 100 grams, it was about 8.19. So now we're at 200. Think about what 10 oscillations would be. So I got about 11.5, 11.50. Might as well put that down. All right, so think about how that compares to the 50 grams and the 100 grams. And make note of how this would compare to the equation from your reading, equation 16.5. So does this support 16.5? Does this refute 16.5? And now we'll go to pendulums. So we've got a little bit more to vary here, and I'm actually going to choose to vary more. I could have made some choices on the other, but I did not. So we're going to start with the length of 0.2 meters and a mass of 1 kilogram, and we're here on the surface of the Earth. So 0.2 meters, I'm going to swing this from 10 degrees, and we're going to go 10 again. So 10 of them at 0.2 meters was 8.96. So now we're going to double it, 0.4 meters. So now think about what we're going to do 10 oscillations again. Think of what 10 oscillations will be. We'll go to 10 degrees again. So think about, is it going to be more time, less time? How much more time? Is it going to be double the time, 4 times the time? All right, so I got 12.72 seconds. So that is a longer time than when we had 0.2 meters. So now we're going to go to 0.8, and you can probably guess whether it'll be longer or shorter. And I'm going to time 10 oscillations again. So 17.93. So with 0.2 meters, I was 8.96, and with 0.4 meters, 12.72, and 0.8 meters, 17.93. So think about that relationship, and how does that fit with equation 16.29 in the book? All right, so now let's just do, let's go shorter again, because we'll go 0.2. No, we'll go 0.4. And so we've already done it on Earth, and that was, we got 12.42. I'm sorry, 12.72. So now we're going to go to Jupiter. Jupiter has a greater gravitational pull than the Earth. So think about whether the oscillations, whether it'll be faster or slower on Jupiter compared to Earth. All right, so on Jupiter, we had 8.1 seconds for 10 oscillations. And all I'm telling you now is that Jupiter has a larger gravitational pull than the Earth. Um, if you'd like, you could actually use formula 16.29 if you're confident about it to determine what the gravitational pull is on Jupiter. And you can put that in the comments. In fact, all of these you can answer in the comments. And now we will, so we did this with 1 kilogram. So now let's do it with a half a kilogram. So think about whether the oscillation is going to be faster or slower. And remember, with 0.4 meters and 1 kilogram, that was the 12.72. Oh, oops, we're still in Jupiter. I want to be on Earth again. Sorry about that. So 12.64. And notice when I did it on Jupiter, I got about 8 seconds. So it looks like when we do it at different mass, we get the same period, whether we're on Earth or on Jupiter. We get different periods with Jupiter and Earth, but the same whatever the mass is. So again, think about how that fits with formula 16.29 in the book.